Hey everybody, this week I wanted to talk about something that actually came up in the course RA class I've been taking, and that's synthetic data. No, I'm not talking about a artificial Star Trek character. I'm talking about what they term as synthetic data, which is basically everything that you guys are used to seeing for generative AI, right? Just taking it a little bit different direction. So, for example, let's say you were looking to have a program figure out what the sentiment was behind things that people have written, right? You've got a sample of some of the stuff that people have sent in, right? Let's take a comments section, right? Or, we all hit things up like if you go to my Twitch channel or something like that, there's chats in there and they have these automated systems that are designed to help moderate those channels. And for good reason. Some of the traffic on those channels can get pretty bad. So let's take that for an example. You're probably going to use something like a sentiment analysis on it. And that's what is the intent of what's being said. People will do that for restaurant reviews, right? Was it a good review? Was it a bad review? In order to train a model to do that, you need to give it good reviews and bad reviews. And you have to label the good ones good and you have to label the bad ones bad so it knows the pattern it's looking for, all right? So if it sees these patterns, those translate to good. And if it sees these patterns, those translate out to bad. Problem is, if you're a good restaurant or you have a good chat group, you may not have enough of the negative stuff, the bad stuff, to make a real representational sample. So you can train your model on it, but that doesn't mean your model is going to be worth much because it has such a limited view of what things are. Now, there's a couple of ways that you can synthesize the data for something like that. And one is to use synonyms, all right? Perfectly legitimate. Swap out certain words, put in synonyms. You may have people that can't type correctly or their grammar is odd. So maybe you swap the words around a little bit or you take a word out here or there or you take out all the punctuation, whatever it is to make up a bigger set using the same set of small data that you had. But what if you then decided to generate data based off of what you're seeing? Well, we know what that looks like, right? We all know about the errors that pop up if you have any of the AIs create text for you. We already know about the other issues that you have with images and things like that. So let's think about that for a minute. What it's going to do is create something that it thinks looks like what was done before. Exact same thing that we do when we ask it to make a paragraph up about something or to tell us about something. It's going to try to put things together in a way that it has seen before. And in this case, you're going to try to make negative comments so that you have a larger selection of negative comments. But that's an entire art in and of itself. Just generating something that looks close to what you had before, and then you have to validate it, right? It's not enough that you just generate this stuff. It has to be validated. Well, is it being validated? They use it for training self-driving cars, for example, because you don't want the self-driving car out. You don't want a hundreds of $1,000 prototype driving in the snow. So you feed it the same input it would have gotten if it was driving in the snow and slid on the pavement. If it tries to brake and it starts sliding forward, all the different things that you would have, you simulate for the car. That's generated data, but it's something that could be captured a little bit, right? Depending on where you are, we already know the physics of how cars traverse and things. But let's say you're working on something more esoteric. You're trying to figure out if your new diabetes drug is going to help diabetics. Or maybe your goal is loftier. You're trying to figure out a way to prevent diabetes in the first place, to find out what the cause is. But there are fewer diabetics than non-diabetics in the population. Still, I think. So by looking at the population, you're going to have a bias because the pattern it's going to be able to recognize is healthy people and not recognize the people with diabetes. The bias that creates could mean that you don't say that somebody is possible for having diabetes when they are. And if you then try to push a drug against it, well, if the sample isn't big enough and it already thinks that people are healthy to begin with, your drug may look like it's going to work when in actual fact it's not because the sample was biased. So they generate medical details to be used for those people. Now, depends on what's being generated. So the big discussion about synthetic data is, should it be used? And I don't think that's the discussion. I think the discussion is, where should it be used? On what criteria is it going to work? Right? If you are doing head flips on a coin, all right, it's a random number, heads or tails, generating more samples so that it can learn a pattern of, let's say you're testing out whether you can flip it with your thumb or just toss it in the air, which one's going to give you more reliable randomness. Generating that out may not be a problem, right? Generating data about people might not be a problem. Ages, weights. You already have a pattern of what most people weigh at a certain age or in a certain part of the country or whatever. So those are pretty straightforward. But there's other things that are less straightforward, right? Like if you're going to be vetting a drug, there are a lot of other elements that you need to have about the body that may or may not be easily replicated. And of course, the problem is you're using the synthetic data to create your model. The model is could do a couple of things. If there's a bias in that data that you didn't notice, it could be biased. It could overfit, meaning it will only fit things that look exactly like that data and not anything that's outside that data, that your generated material is too close to the actual material, or all of the generated material is too alike to each other, that it doesn't give you that wide enough grouping. Remember we were talking about comment sections. Putting synonyms in is a good way to expand your pool of material without changing the actual intent behind what was said, but broadening the range of what the program would recognize under a particular sentiment, one way or the other. So that's one way you can get it to go, and it is a simple process, right? It's easy. You're matching what was there before. What isn't as easy is some of the more medical stuff, right? They use it to generate x-rays. Well, a doctor can take a look at the generated x-rays and determine if the generated x-ray is close enough or varied enough that it can be used for something else. But again, you're not just letting the system generate it. In one of the examples that I saw, the generated data was to level up the playing field, right? If I have a 200, let's say, of positive comments, and I've got 50 of negative comments, well, I generate another 150 negative comments, so I've got 200 to 200, right? That gives it neither one is a majority. So you won't have a bias against it because it's got a different majority to it. But here's the problem. What came out wasn't that much better than what was before, which could mean that the data was just too close to what was there, or the generated data was too widely apart from it. We all know when we saw these generated images of people that had 6 fingers, for example, where the hands were deformed. One of the examples that I saw, they asked if which picture was the fake, and in one picture, the woman has her arms crossed, right? So the hand's underneath the arm, okay? You can see the wrist, the hand's high up, and you can see the knuckles touching the side of her body. That's one really long hand. So things generated with stuff like that, if you really don't have a person vetting this stuff, and that's what they're trying to do, is just get past that and just generate things quickly and crank things out faster, that's going to cause problems. It's inherent in the fact that the generated images or the generated data is not real data. We used to do these things called Monte Carlos, which basically a gambling way of synthesizing statistics. And what it was typically used for was to prove the point that the person was trying to make. It wasn't that it was really trying to vet out if the process was going to work or not. You could just play with the odds, if you would, and get it to do whatever you wanted to. You do the same thing with simulated data. So it's a balancing act. The problem is you don't have enough of the particular data that you want. Like you may not have enough derogatory comments or defamatory comments because your chats are not that bad. And you don't want to go to Twitter to go pick up a bigger sample. So how do you train out something that's going to help you go through all of your comment section and know what needs to be flagged and what needs to be removed? I've got comment sections on my websites. I have them all turned off. Anything that gets posted, I have to review. Well, it doesn't make for a very conversational comment section if every time somebody makes a comment, I have to go see it and review it. It kind of slows the process down. On the flip side of that, I haven't seen anything that's popped up that I want to lit through. So generative data has a place, but I think we need to be very concerned about what data is being generated and how it's being vetted on the other side. What is actually being done to make sure that the data that got generated looks close enough to the real data that it's going to be useful? And who's doing that? Are we allowing the thing to just generate stuff on the fly and then hoping that it works? The example that I saw, I didn't see any step in there where they were vetting the data that was created. Just, oh, well, I have another 150 items. Well, are those valid? They're all tagged as being derogatory or being negative comments and sentiment because we generated them against a set of 50. But that doesn't mean they're good. And it doesn't mean that they're a broad enough spectrum of comments that it's actually going to work. So I want to bring this up this week because it's another side of generative AI, right? The side you're probably used to thinking about is talking to ChatGPT or one of those chatbots, or having something render an image for you, right? And if you're wondering why these data centers are consuming all this power and all the memory and processors and things, that's why. Because if they're generating data, especially if you're talking about a self-driving car, that's an awful lot of stuff to generate. They're creating simulations for the AI that's going to be driving the car. Same thing for anything going through an office. I don't know if you guys have seen them. They've had them around for years. The federal government was one of the first ones to have them. I don't know if they still do or not, but they had mail robots. I don't mean gendered, I mean male. That would follow a path on the floor and stop at certain places so people could get their mail. That's all it did. I don't even think it announced that there was mail there. And it would stop at certain places. People could come over and you could stop it and you could add mail to it and it would continue on its way. It was basically a bookcase on wheels. That was pretty much all it was, but it got the job done. Now, that's a very simplistic thing, but you could train something like that with that kind of simulation because somebody could walk across in front of it. It needs to know to stop. Somebody could come up to it and tap it, or however they got the sensor set up because they're bringing a package to it. It needs to know to stop. So rather than putting that in an office and having people get frustrated because it's not stopping or hit somebody, you can generate these things up as a potential, a simulation that that will allow it to act as if it's actually delivering stuff as far as the AI is concerned, with the same inputs that it would be getting if it had actual sensors attached that it could read, and simulate those kinds of things out. That's pretty straightforward. If you're talking a hospital, well, that could be a lot more chaotic depending on what part of the hospital it's used in, right? If it's used in the emergency room, chaos reigns. If it's being used in the pediatrics ward, that could be a problem too, depending on how the kids are getting around. So you can see the complexity go up. From there, think of a self-driving car and all the things that you see when you're out driving, either as the driver or as the passenger. People opening doors in front of you, people moving. What is the car going to do? And when it's being simulated, there's no real consequence if it runs over somebody. There's no consequence if somebody opens a door and they slam into the door. There's no real world consequence if it has to make a choice between the two as to which is the better option, other than a hard slam on the brakes, because the hard slam on the brakes could put the passengers and the driver in danger. Hitting the person, obviously not a good thing. Hitting the door, obviously not a good thing. Sometimes when we're driving, we have those kinds of things pop up. Not something you want to train a self-driving car on, obviously. But that doesn't mean that the simulation was done well enough that the self-driving car could then bring that forward. Because the data that was simulated, if it is too similar to what it saw before, it might need all three of those conditions, for example, to be there, and might miss if one of those conditions isn't present. Or conversely, it might think the conditions are there and respond accordingly, even though they're not. And that's probably what you're seeing with some of these cars that either slow down or stop or swerve. There's something in there that is getting a false positive, thinking that there's a condition being met that means it needs to do something. That, it it can't deal with. Now, if all of the cars were self-driving and they were clustered. Now, what do I mean by clustered? Well, think about drones. If you've ever seen a drone show, they have some drone shows that actually simulate fireworks, right? Or replace fireworks. They're clustered in that they can communicate with each other and know where the other drone is. If you have a self-driving car going down the road that suddenly swerves, if the cars are clustered, then they would know that that was going on and could respond appropriately to that car that's acting incorrectly. But we don't have that. We have humans on the road with self-driving cars, and if the self-driving car misbehaves, the human may or may not see it coming. It's just the way it is right now. So we have simulated data to try to get around that. But again, the pace at which things are going seems to indicate that they are not doing a proper job of vetting the simulated data. And if you've had a picture generated or some of the other stuff, yes, it's gotten better, but how many years has it taken for it to get better? Right? So there's a lot of things that are good about simulated data, and there's a lot of things that are bad about simulated data. Just don't forget, simulated data can also do deepfakes. They can make something just like, and it was years ago that we could do this. You could have you could ask something to write in your voice or in somebody else's voice, and it would do that by looking up the material that that person wrote and making the tone, the words, etc., so that it would appear to have been written by that person. Right? We've always had that. It was great if it was something that you wanted to do. Not great if you were a student cheating. But if you were writing something and you were running into a block and you're doing marketing material, for example, you could have it right in your voice and come up with something that would match the way you talk, the tone of your voice, if you would. So you could do that. And again, that needed to improve. All of this stuff needs to be improved. But right now, all they're doing is creating huge data centers, not to improve it, but to monetize it. And I don't think we're there yet. But that's what I want to do, is talk to you this week about the realm of simulated data. That it has a good side, has some bad sides. That's what I got for you guys this week. Talk to you all next week.